саламатсыздар ма, құрметті студенттер? Алгебра есептерін шешу практикумы сабағын ағылшын тілінде жалғастырамыз. Бүгінгі тақырыбымыз логарифмдік теңдеулерді шешуге арналады. Яғни логарифм теңдеуді шешу жолы мысалдарымен қарастыратын боламыз. Today we consider logarithmic equations, and after this lesson, students will be able to solving logarithmic equations. Definition: relationship between logarithmic and exponential form. For x greater than 0 and a greater than 0 and non-equal to 1, the logarithmic form, this logarithmic form is equivalent to the exponential form. This exponential form, which allows us to convert from one form to another once we identify a, x, and I. An exponential function I equal to a to the power x is the inverse of the logarithmic function. I is equal to log base a of b. This means if you raise a to the power of log of x with base a, or if you raise a to the power of x first, then take the log with base a of the result, you get back x. The relationship between logarithmic and exponential forms give to deduce the properties satisfied by the logarithmic forms known as the laws of logarithms, that follow from the laws of exponents. Let's recall the laws of logarithms. To solving logarithms, first step is always to try to simplify using the log rules. So to solve any logarithmic equation, we use this algorithm. First, use known log rules. By using known log rules, we will try to simplify the given equation. And next, isolate the logs. There are two possible cases. The first type look like this. If you have a single logarithm on each side of equation having the same base, then you can set the arguments equal to each other and solve them, this given equation. And the second type, if you have a single logarithm on one side of the equation, then you can express it is an exponential equation and solve this equation. And next step, solve the resulting polynomial algebraic equation. And of course, next step, check the solution. So consider the example, solve the logarithmic equation. So according the above algorithm, first, by using known log rules, we simplify the given equation. We use the product and quotient rule of logs. So it means that when we adding the log of the logs of the same base, we can rewrite this expression as single log by multiplication of these arguments. And when we consider the subtraction of two logarithms, we can rewrite this as the single log by the division of each arguments. So according these two rules, we rewrite the given equation in this form, and such that the base of both sides, the base of logarithmics in both sides are same. We can isolate the logs. We have a single logarithm on each side and equation having the same base. Then we can set arguments equal to each other. So we drop logs and equalize the arguments. And after this process, we take this polynomial or algebraic equation. In this case, we take this rational equation. And next step, we solve this resulting equation. To solve this resulting equation, we find the common denominator and transform to the quadratic equation. And this solution of this quadratic equation is equal to these numbers. And of course, we must check these given solutions. We check our answers to make sure they are valid. So by plugging into X the first solution, we take that we see that the equality is valid, and this solution is correct. And by checking next solution similarly way to first case, we can show that this solution is rejected because the logarithm of negative number is undefined. So the solution of the given logarithmic equation is equal to 2/3. And next example, solve logarithmic equation in this form. First of all, we using non-log rules. In this case, use the product rule and combine the logs. Or after that, I take this form. Next, I need to isolate the logs. We have a single logarithm on only one side, namely the left side of the equation. Then we can express it as an exponential equation and solve it. So change the exponential form and solve this given equation. Multiply all the expression and take this quadratic equation. So the solution of quadratic equation is r equal to -4 and 2. Next step, check each solution. We have checked both answers. For that, into X plug -4 and and 2. After that, we say that -4 is not solution. We cannot take logarithm of negative number, and the solution of this logarithmic equation is equal to 2. So as homework, you may take these logarithmic equations. You may solve these logarithmic equations by using above algorithm, by using this algorithm. So that's all that I have. Thank you for your attention. Сонымен бүгінгі негізгі өткен тақырыбымыз логарифмдік теңдеуді шешудің алгоритмі, яғни бұл жерде алгоритм бойынша ең алдымен белгілі логарифмдік қасиеттерді қолданып ықшамдап аламыз. Using the log rules, we will try to simplify. Яғни бұл жерде ықшамдау қажет болса ықшамдаймыз, болмаса берілген әрі қаратай жалғастырамыз шешуді. Содан кейін екі жағдайды қарастырамыз. Екі жағында бірдей негізді логарифмдер болса, онда логарифмдерін алып тастап тек қана аргументтерін теңестіреміз. Егер бір жағында тек логарифм болса, онда экспоненциалды теңдеу түрінде жазып аламыз. Яғни шыққан теңдеуді шешеміз. Яғни бұл жерде if you have single logarithm on each side of the equation having the same base, we can set the equal each other of this equation. Яғни екі жағын теңестіремін. Енді екінші жағдайда you can express it is an exponential equation. Мына түрге келтіріп аламыз деген сөз. Сонымен бүгінгі тақырыбымыз аяқталды. Тыңдағандарыңыз үшін рахмет. Сау болыңыздар.